Hello viewers, welcome to my channel. I'm Hasham. Last video I have completed two problems on measure of skewness. So we have completed two problems on Carl Pearson method. In this video I am going to explain you about Bowley's coefficient of skewness. So before starting the problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Without problems you cannot understand any lecture. So always keep ready the problems. Take a screenshot of the solutions of problem number 3 and 4. Then I'll explain. Come on, see the problem number 3. For a moderately skewed data, the arithmetic mean is 200. The coefficient of variation is CV, is 8, and SKP, Carl Pearson's coefficient of skewness, is 0.3. Find the mode and median. So only it is asking you to calculate mode and median. The only thing you have to remember the formula. First we write down mean is given in the problem 200. Coefficient of variation, it is given as CV, is given as 8. SKP is 0.3. We have to calculate mode and median. CV, coefficient of variation. This I have already explained in the last videos of measure of dispersion. Measure of dispersion. It's a relative measure. The formula for coefficient of variation is standard deviation by mean into 100. Already we have discussed, we have done so many problems. So standard deviation. First of all, CV is given in the problem 8. In place of CV, I am writing 8. Standard deviation is not given in the problem. So first we calculate standard deviation by using the formula of CV. So standard deviation divided by mean. Mean is given in the problem 200 and into 100. Now remove, cancel these two zeros. These two zeros will get cancelled. So 8 is equal to standard deviation by 2. Now if we make a cross multiplication, standard deviation is equal to 8 to the 16. That's all. So we got standard deviation 16 by using the formula of CV. Now SKP formula. The formula for SKP, Carl Pearson's coefficient of skewness, is mean minus mode by standard deviation. This is the formula for skewness. So SKP is given in the problem 0.3. In place of SKP, I am writing 0.3. Mean is given in the problem 200. But mode we don't have. We have to find out mode. Divide by standard deviation. Just now we have calculated 16. Now if we make a cross multiplication, 0.3 into 16 is equal to 200 minus mode. 200 minus mode. So first you multiply 0.3 into 16, you get 4.8. So 4.8 is equal to 200 minus mode. Take the mode to LHS. Right now it is on RHS. So minus mode will become plus mode. And bring this 4.8 to RHS. So plus 4.8, here it will become minus 4.8. So ultimately mode is equal to 195.2. So first answer we got mode value 195.2. Now it is asking you to calculate median. There is a formula. Mode is equal to 3 median minus 2 mean. Mode is equal to 3 median minus 2 mean. This is the relationship formula in statistics. So mode already just now we got 195.2. 3 into median. Median we don't have. We have to calculate. Minus 2 into mean. Mean is given in the problem 200. In the whole equation only median is unknown. All other values are known. So 195.2 is equal to 3 median minus 200 into 2 is 400, right? Now 195.2, take this minus 400 to LHS, so it will become plus 400 is equal to 3 median. So for 195.2 plus 400, 595.2 is equal to 3 median. Median is equal to 595.2 divided by 3, you will get 198.4. This is the median. So in the whole the problem it is asking you to calculate mode and median. Mode we got 195.2 and median we got 198.4. Only thing you have to remember the formula. So many formulas are there in statistics. Now calculation of Bowley's coefficient of skewness. Next problem, problem number 4. Calculate Bowley's measure of skewness from the following data. Payment of commission 100 to 120, 120 to 140, 140 to 160, 160 to 180. Like this continuous series is given last 280 to 300. And number of persons, these are the frequencies: 4, 10, 16, 29, 52, 80, 32, 23, 17, 1. It's a continuous series and it is asking you to calculate Bowley's coefficient of skewness. Bowley's coefficient. We don't require mean, we don't require median, we don't require standard deviation, mode. We need only median and quartiles. For Bowley, we need median and quartiles. So we require CF column, cumulative frequency column. So commission, whatever is given in the problem, same thing I have copied. Number of persons, frequency, I have copied the same thing, whatever is given in the problem. Now CF, cumulative frequency. Already while calculating the median, we have seen how to find out the cumulative frequency. First one 4, 4 plus 10, 14, 14 plus 16, 30, 30 plus 29, 59, 59 plus 52, 111. Like this we have calculated CV. The last CV is, CF is 270 and the total of frequency you must get 270. If both these are same, then your calculations are right. Now we'll calculate the median first. So median is equal to median class. First of all, you have to find out the class interval in which median lies. The median class is equal to n by 2. How much is n here? 270. So 270 by 2, 135. Now locate 135 or next higher in CF column. Corresponding class is the median class. So 135 or next higher, 191. 135 we don't have. Immediately higher to 135 we have 191. Against the class interval 200 to 220. So our median class is 200 to 220. 200 to 220. Now median formula, median is equal to L plus n by 2 minus CF by F into I. This is the formula for median. L stands for lower limit. What is the lower limit here? 200. 200. N by 2, already we have calculated n by 2, 135. CF. CF means cumulative frequency of the class preceding the median class. Before the median class. The median class is 200 to 220. Here 200 to 220. Before this 200 to 220, we have 180 to 200. What is the CF for this one? 111. So 111 is the CF. Cumulative frequency of the class preceding the median class. Before the median class. And F stands for frequency of the median class. The frequency of the median class is 80. F is 80. So CF is 111 and F is 80. 111 and 80 into I. I is the width of the median class. What is the width here? 220 minus 200 is 20. Now 200. 135 minus 111 divided by 80 into 20. If you do all this, you will get 6. So 206 is the median. So we got the median. Now we'll calculate the quartiles Q1 and Q3. First lower quartile Q1. Same procedure what we have done for median. Same method, only difference is denominator instead of 2 we will take 4. For median we have taken 2 and quartiles will take 4. That is the only difference. So first Q1 class is size of n by 4. 270 by 4, 67.5. Now locate 67.5 or next higher in CF column. Corresponding class is the Q1 class. So 67.5 is 111. 111 is higher than 67.5. Right? So what is the class interval here? 180 to 200. So 180 to 200 is the Q1 class. Now Q1 is equal to L plus n by 4 minus CF by F into I. Same formula. Here denominator 2, here denominator 4. That is the difference. Lower limit 180 plus n by 4 67.5. CF is the cumulative frequency of the class preceding the Q1 class. Q1 class is 180. तो 180 to 200 इससे पहले का 160 to 120 इसका CF 59. तो 59 is the CF and frequency is 52. तो 59 by 52 into I width. Width is 20. So 180 plus 67.5 minus 59 divided by 52 into 20, you will get 3.27. So 183.27 is the Q1, first quartile. Next Q3, upper quartile. Same procedure. Now we take 3n by 4. Upper quartile will take 3n by 4, 3 times. So 3/4. So 3 into 270 divided by 4, you will get 202.5. Locate 202.5 or next higher in CF column. 223. 223 is higher than 202. So against this, what is the class? 220 to 240. 220 to 240 is the Q3 class. 220 to 240. Now formula, same formula. L plus 3n by 4. Here we have taken only n by 4. Here we are taking 3n by 4 minus CF by F into I. Same. So L lower limit is 220. 3n by 4 already we got 202.5 minus CF. Cumulative frequency of the class preceding the Q3 class. Q3 class is 220 to 240. So before this it is 191. So 191 by 32. So here 191 by 32 into 20. So 220 plus 202.5 minus 191 divided by 32 into 20. If you do, you will get 7.1875. Now add up. 227.1875 is the Q3 upper quartile. For calculating Bowley's coefficient of skewness, we require median, we require Q1, we require Q3. All the three things we have calculated. Median, Q1 and Q3. Now substitute in the formula. Bowley's coefficient of skewness SKB is equal to Q3 plus Q1 minus 2 median divided by Q3 minus Q1. That is the formula. Substitute the values. Q3 227.1875, 227. Plus Q1. Q1 is 183.27. 183.27 minus 2 into median. The median is 206. So 2 into 206 divided by Q3 minus Q1. 227.1875 minus 183.27. So first you open the bracket. 206 into 2 is 412. Now 227.1875 plus 183.27 minus 412. You will get minus 1.5425. Divided by 227.1875 minus 183.27, 43.9175. So if you divide, you will get 0.035 minus negative. The skewness may be positive or negative. Positively skewed or negatively skewed. So here we got negative. Minus 0.035 is the coefficient of skewness as per Bowley's formula. That's all. So in this video, two problems I have solved. One, calculating the mode and median. Remember the formula. Second, a continuous series is given. And from this continuous series, how to calculate the Bowley's coefficient of skewness. That's all. Inshallah, we'll continue the next problem in the next video.